class. I wanted to do a quick video on today's worksheet, on Monday's worksheet about chemical bonds. We got a little ways into this, but not too far. I just wanted to do a quick overview of the answer key without going into a lot of detail. You got all the answers there to look at, but I wanted to talk a little bit more about how you got the answers. So if we look at our first problem here in our worksheet, that's how and why are atomic bonds formed. Well, the how here, you see the bonds are formed by transferring or sharing the valence electrons. That's the how. And why are they transferring and sharing those valence electrons? It's because the atom wants to be stable. It wants that full outer ring. And once it has that full outer ring, that full outer shell, it's stable. Remember, stable doesn't mean that it's neutral. Stable means that it's got a full outer ring, full outer shell. Then we went into problem number 2 here, and this was more. We did several of these in class. We want to write down our full electron configuration, and then it says to circle the valence electrons. Remember to find the full electron, to find the valence electrons, just look and find the highest energy level here, find the highest energy level, and then you can circle everything that is in that energy level. So for carbon, energy level 2 is our highest. Let's put our circle around the 2s2 and the 2p2. And let's count their electrons. That's going to be the higher number here, number up at the top here, the 2 there and the 2 there, right? That's going to add up to 4. Let's look at krypton real quick. Again, we wrote out our full electron configuration. We look at what's our highest energy level, and we see that it's 4. Got a 4 there and a 4 there, so that's our highest energy level. Not our 3, right? Our 3D, we're not excluding here. That's in our 3rd level. We're looking for things in the 4th level. So how many electrons do we have here in the 4th level? We got 2 from our S. We got 6 from our P. That gives us a total of 8 valence electrons. And we're going to do the same thing going on down. Highest energy level, circle whatever's in that highest energy level. And then count your electrons that you circled. Question 3 asks, are any of these elements stable? Well, yes. Which one's already stable? Our krypton's already stable. Why is krypton already stable? It has 8 valence electrons. It already has the 8. It doesn't need to gain any. It doesn't need to lose any. It's already in its stable state of 8 valence electrons. Next question here, we're talking about how are cations formed? How are anions formed? Questions 4 and 5. Remember cations, think of that T there. It kind of looks like a plus sign. Anions, so it's plus or a positive. Anions have an N here, think negative, right? A cation, if it's going to be positive, what happens is the atom gives away its some valence electrons. If it loses some negative charges, what's happening? That means there's more positive protons left, and we're going to have a positive charge. And we look at our periodic table, what elements like to do this? It's our metals that give away their electrons. Anions are negative. Remember that N there for negative. How are they becoming negative? Because they pick up some electrons. They gain some electrons. Electrons are negative. That leaves the atom with a negative charge. And then we saw our nonmetals are the ones that like to gain electrons. All elements want the electron configure of which group? They want to be noble gases. Why? Because we know that when it's got satisfies the octet rule, when it satisfies the octet rule has 8 valence electrons, that's when it's the most stable. Real quick on this last piece then, guys, I know this is different. We did not get a chance to go over this in class, but I want to talk to it here. And this question asks us to draw what will happen with the valence electrons when the following elements react. So I'm going to go through 2 of these just to show you the idea that we're after. So what we're doing, it gives us our 2 atoms. It gives us a potassium atom. It gives us an iodine atom. And what we're going to do, we're going to put the symbol down here, put our K for our potassium, and we're going to look at our periodic table. We see potassium's in group 1. That means it has 1 valence electron. So we're just going to put that 1 valence electron outside our potassium atom like that. Okay? We look at our periodic table for iodine, and we're going to see that it has 7 valence electrons. So if you look around this iodine atom, we've got 7 electrons there. Well, then it's going to transfer the electron, and that's what we're meaning by here. So we circled our potassium electron, show that it's going to be moving over, and it's going to be taken away by our iodine atom. Potassium lost one electron, so it now has a positive 1 charge. Iodine gained 1 electron, so it now has a negative 1 charge. All right. Let's look at the magnesium next. And then Let's see. Then we'll look at a sodium because I want to show you something that has multiple atoms. We look at magnesium on the periodic table. We're going to see magnesium's in group 2, right? So that means it's got 2 valence electrons here. Iodine, we're going to see iodine is in group 7. We saw that earlier, right above. That means it's got 7 valence electrons. 7 valence electrons. So what's going to happen here? Well, the iodine, it only needs 1 more, right? So the iodine I have drawn here on the right, it's going to take 1 electron. That fills up this iodine. Now this iodine has 8 electrons. Well, our magnesium still has another electron it's got to give away. So we need a second iodine atom here to take that other second electron from that magnesium. Then our magnesium's lost its 2 that it wanted to. This iodine has a full shell of 8 here. The first iodine has a full shell of 8 here. And when our magnesium lost its 2 valence electrons, it falls back 1 level in its energy levels for its electrons. It's got a full electron shell there. So I want you to be careful when you're looking at how many of each atom do you need. We look at sodium again, kind of like the iodine one here, right? Oxygen, it needs 2 electrons. It's group 6, it needs 2 electrons. Sodium can only give away 1. So if oxygen needs 2, it's going to need 1 sodium atom to give it 1 electron, another sodium atom to give it the second electron. This is going to lead us down to what we're going to see here in the next few weeks about balancing chemical equations and balancing molecules. We're going to learn about that real soon. So this is just, again, a quick summary of what we saw in the for the worksheet, the answer key for today's worksheet. I just wanted to speak to it a little bit to help out. Thanks a lot, guys. Bye.